All right, we're going to do 6.1. This is just basic review on how to solve equations, so we're going to skip that right now. And we are going to start solving inequalities today. So an equation, obviously, we know what an equation is, and it has an equal sign. An inequality doesn't have an equal sign, it has an inequality. So that's the greater than, the less than, the greater than or equal to, or less than or equal to. So that's what an inequality is. You have to be able to tell the difference. I think the easiest way is that the less than sign looks like an L that just got smushed, like a capital L that got smushed down. Okay, so this one is the less than. I know that you can say like, oh, the alligator eats the bigger number, which is fine, that's true. So if you have like a 3 is less than 5, then obviously 5 is the bigger number. But you still have to be able to look at it and know it's a less than sign, not just which one's bigger. You have to know what that actual sign is. So that's the less than. Flip it around, that's greater than. When there's a line underneath it, that is less than or equal to. So that line underneath means it could also be that number. So if I have something that says x is less than or equal to 5, okay, so it can be less than 5, it can be 4, it can be negative 17, it can be 0. But the fact that that line is underneath it means that it can be 5. So 5 is also a viable solution. If you just have x is less than 5, then 5 is not part of your solution set. Okay, so that equal to just adds this number as part of your answer as well. And then you flip it around, and that's your greater than or equal to. And that's it. Hopefully you can get used to looking at them and knowing which one's which. Make your lives a little bit easier. All right, you're going to solve them just like you solve regular equations, okay? So right now we have t minus 45 is less than or equal to 13. To get the t by itself, you have to add 45 to both sides. Nothing about this is any different than normal. So t is less than or equal to, and then you just add 13 and 45 and you get 58. T is now by itself, so that's your answer. T is less than or equal to 58. Now, the only difference is that if you're thinking about the actual solution, 58 isn't the only answer. Like before, if I got x was 7, I could just say my answer is 7. That's not true anymore. T is less than or equal to 58. So it can be 58, or it can be 56. It can be 57.5. It can be negative 2.3. It can be anything that is smaller than 58. So that makes a little bit of a difference, and we'll talk about that when we go to graph these. This one says 7 is less than x plus or x minus 4. So we're subtracting 4. So the opposite of subtracting 4 is adding 4. So 7 plus 4 is 11, less than x. Okay, that's the answer, and that's perfectly fine. If you are thinking specifically about which numbers x could be, you have to be careful because 11 is less than x, but that means that x is greater than 11. Okay, you can rewrite it. Just make sure the alligator was eating the x before, my alligator is still eating the x. So it's fine to write it with your variable first, and when we get to graphing, that might be easier. You just have to make sure if you choose to rewrite it, you keep that symbol eating the same number it was eating before. Okay, so in this case 11 is bigger than x, so my answers would be like 12, 20, 92. It has to be greater than 11. It cannot be 11 because it's not equal to. All right, so this time r is being added to a positive 19, so you're going to subtract 19 from both sides. Just leaves you with a positive r is greater than or equal to negative 3. And that's it. Just solve it normal. Okay? We can write our answers in what we call solution sets. Okay? So they look a little goofy, but we have to at least be aware of what they are. So sets always have the squiggly brackets. We knew that. And then you always put your variable, and then this vertical line, that means such that, and then what you learned about your variable. So you would read this as t such that t is less than or equal to 58. Okay? That just means that it's just a fancy way of writing it. You identify your variable first, t, and then your such that sign, and then what you know about your variable. We know that it's less than or equal to 58. Okay? We can graph these. Since these are only one variable, then you're going to graph them on a number line. We will graph them on a coordinate plane, like we graphed lines later when we have two variables, but for right now they're single variables, so we're going to graph them on one dimension, so just on the number line. Okay, now if I have t is less than or equal to 58, okay, the way we're going to graph that, is that what I have on the next slide? Oh, okay, we'll just do it on this one. So we already solved this one. We added the 45, and we got that t was less than or equal to 58. We did this before. Okay. So here's my answer, and it's only one variable, so I'm going to graph it on the number line. And that's pretty simple. All I'm going to ask you guys to do is put your answer in the middle of the number line. So our actual answer was 58. And then just do one above and one below. Okay, so one before 58 is 57, one after is 59. So I'm just asking for 3 tick marks, your answer in the middle. All right, now what we have to think about is, can our answer be 58? Okay, yes, because of the equal to. So the fact that we have that line underneath means that we are going to put a dot on 58 that is solid. Okay, it is a solid filled in dot. Okay, then we know that it's not just 58. If it was equals 58, then we would be done. But it's less than or equal to 58. So then you have to come up above and you have to shade or put an arrow in the direction where all of the numbers are less than 58. Okay, so the numbers that are less than 58 in this case are to the left. So I need an arrow going to the left. That means everything over there continues to go to the left, is part of my answer. So the solid circle, solid makes a difference. So solid, because it's less than, because it's equal to, okay? So the fact that there was the line underneath the inequality means that this dot has to be solid. And then we go to the left because it's less than. So those are the two things we need to think about. Dotted or solid, and then which direction we need to shade. Okay? So let's look at this one. We add the 4. We get 11 is less than x. We talked about this one earlier. We can also write it as x is greater than 11. It's easier to graph it this way. Okay? We need 3 numbers on our number line with our answer in the middle. So we're going to do 11 in the middle. Obviously 10 is before that and 12 is after that. Okay? X is greater than 11. 11 this time does not get to be part of my answer. It's not less than, or it's not greater than or equal to, it's strictly greater than. However, 11.00001 is bigger than 11. We cannot physically graph the first number that is bigger than 11. That's impossible because it can be 11 point and then 1,000 zeros and then a 1. That's bigger than 11. So we can't physically graph that. So what we have to do is we still have to include the 11, except this time we're going to put a circle on it, an open circle, because 11 doesn't get to be part of my answer, but anything after 11 does. Okay? It is greater than, so we're going to come up, and we're going to, okay, which direction are the numbers that are bigger than 11? That's to the right. So my arrow this time is going to go to the right. So in this case, this is open, because it's not equal to, okay? And we're going to the right because it's greater than. okay? So those are the two things you have to think about. Now, an easy way to help us remember this is important, as long as your variable is listed first, then your inequality is like a little arrow pointing in the direction that you need to shade. So the less than's pointing to the left. Again, this only works when your variable comes first, but when our variable came first, that little inequality is pointing, the arrow is pointing in the direction we need to shade. Okay, so it kind of tells you that, but you have to make sure that your variable is first in order for that to work. All right. So these are the things we just talked about. You need to decide if your circle is going to be open or closed. Okay, open or solid. Shade to the left if it's less than, to the right if it is greater than. And then put an arrow at the end of your shaded area because you have to make sure you indicate that it keeps going in that direction. Okay, it doesn't stop just when your little line stops. All right, I'll do a couple of these with you. Subtract the 4, we know how to do that. A is less than 2 minus 4 is negative 2. My variable is first, which is helpful. My number line needs to have a negative 2 in the middle. Now be careful with your negative number lines. The number that is one less than negative 2 is negative 3. Negative 3 is smaller than negative 2. And then to the right is negative 1. Okay? This is going to be open because it is not equal to. So you have an open circle on negative 2. And then it is less than, and the numbers that are smaller than negative 2 are going to be to the left. So open to the left. This one, we're going to subtract the 4 from both sides. 9 minus 4 is 5. So we have b is less than or equal, or 5 is less than or equal to b. Now, there's nothing wrong with that. Personally, I think it's easier to comprehend if my variable comes first. So I'm going to flip it. The alligator was eating the b before, so it still needs to eat the b now. It was equal to before, so it's still equal to. Okay? So my 5 is going to go in the middle of my number line. And that's just a normal positive number, so it's straightforward. 4 is to the left and 6 is to the right. It is equal to, which means the dot on the 5 is going to be solid. Okay, solid because it's equal to. And make sure I can tell the difference between your dotted and your solid. And then it is greater than, and the numbers that are greater than 5 are to the right. So we are going to shade up and to the right. Okay, last one, t minus 7 is greater than or equal to 5. So we add that 7 to both sides, so that gives us that t is greater than or equal to 12. Okay, so 12 is in the middle. It's normal, so just 11 to the left and 13 to the right. There is a solid line underneath your inequality, which means the circle you are drawing has to be solid on 12. And it is greater than, and it's also pointing to the right. So I'm going to shade to the right. Okay, again, this is like a little arrow telling you which way to go. Okay, as long as your variable comes first. And then that's it. If you haven't noticed, all of the ones that we have done right so far have been adding and subtracting. There is one little trick when you are multiplying or dividing with inequalities you have to be careful of. I'm not going to take the time to do this right now, but you just need to understand. I'll just show you a really quick example. If I have negative, no, I'm not going to do that. You just need to know if you multiply or divide by a negative number in an inequality, you have to flip the direction of the inequality. So if you multiply or divide by a negative, if you leave your inequality the same, then it's not true anymore. Okay, so you need to flip it in order to make it true. You're going to flip the direction of that inequality when you are solving if you multiply or divide by a negative. If you're multiplying or dividing by a positive, you leave it alone. Okay, but we need to get in the habit of stopping when you multiply or divide at all and see, okay, is this positive or is this negative? Do I need to change it or not? So this is a b over 7 is greater than or equal to 25, okay? So b is currently being divided by 7. So the opposite of dividing by 7 is multiplying by 7. So we are going to multiply both of these sides by 7. Okay? The second you say multiply, you stop. And you say, what kind of a number are you multiplying by? Are we multiplying by a positive number or a negative number? We are multiplying by a positive 7. The fact that we are multiplying by a positive 7 means you do not change that direction of your inequality. You leave it the same. And then 25 times 7 is 175. So it got to stay greater than or equal to because this 7 was positive. Okay? That 7 is positive. So we do not flip. Okay? Now, this is a 2/5 p. I know it's hard to read, so I'll rewrite it. 2 over 5 times p is less than negative 14. Okay? Right now, p is being multiplied by negative 2/5. So you have to do the opposite of that, which is to divide by negative 2/5. So divide by negative 2/5, divide by negative 2/5. The second you say divide, you stop and you ask yourself, what kind of a number are you dividing by? In this case, we are dividing by a negative number, which means you have to flip your sign. So the less than sign is now a greater than sign. And negative 14 divided by negative 2/5 is a positive 35. So since the number you divided by, this number, was negative, you must flip. Okay? So if the number you're multiplying by is positive, you're fine. If it's negative, you have to flip it. Okay, so 14h is greater than 91. So currently h is being divided or multiplied by 14. So you are going to divide by 14. The second you say divide, you stop. What kind of a number are we dividing by? We are dividing by a positive number, so you do not flip it. You leave it the same, and then you divide it out, and you get 6.5. So h is greater than 6.5. Okay, we have a negative 5t is greater than or equal to 275. So t is being multiplied by negative 5, so you are going to divide by negative 5. The second you say divide, you stop. What kind of a number are we dividing by? We are dividing by a negative number, so we have to flip the inequality. It used to be greater than or equal to. Now it is less than or equal to. Okay? The line stays underneath the inequality, but the inequality just has to flip around. And then divide them out, and you get negative 55. So your final answer is now t is less than or equal to negative 55. Okay? So just be careful. Multiply or divide by a negative, you flip it. If you multiply or divide by a normal positive number, you don't have to flip it.